Welcome for those who couldn't join our morning session, and welcome back for those who were at the morning session today. So my name is Natalie Lamb. I am the Innovation Delivery Manager at Spring. Apologies for all of the pinging that you can hear on my end. I would love to introduce you today to Thomas Walker, the Senior Innovation Manager at Spring. So Thomas actually leads the innovation program at Spring, overseeing both the accelerator and the development of Spring's innovation offerings. So throughout his career, Thomas has helped to build and scale the innovation capabilities of both for-profit and not-for-profit organisations. Drawing from his experience of a range of disciplines and industries, Thomas is consistently able to turn the complex and messy world of innovation into real-world impact. Over to Thomas for our introduction for this afternoon session.
Thanks, Natalie. Afternoon, everybody. Welcome to the second half of the Spring Accelerator 5 Ambition Surgery. This is the launch event for our upcoming accelerator program inside Water Innovation Strategy Theme 6, which is taking a whole life approach to responsible consumption and production. And as Natalie said, specifically, we're looking at leakage and bursts today. So my name is Thomas. I'm the Senior Innovation Manager at Spring. And similar to this morning session, I'm going to do a slightly shorter, actually, introduction to this part of the event before handing back over to Natalie and the rest of the speakers, and popping up once or twice throughout this afternoon. So Spring is an innovation accelerator that enables collaboration within and beyond the water sector to drive transformational innovation. Now, instead of going through a full introduction again, I'll just remind you all that fundamentally we exist to increase collaboration, reduce duplication, and accelerate learning. And we have two parts of our business that help us do this. We have a knowledge transfer side, which we host showcases, which are sort of 2-hour deep dives into projects that help people learn and accelerate their own efforts in similar spaces, and have a library of case studies on our platform. And we have the innovation side, which at the moment is characterized primarily by the Spring Accelerator and is the reason that we are all here today. Speaking to the Spring Accelerator, it is an end-to-end challenge process that calls out for specific implementable innovation for water companies to trial, progress, and adopt as a collaborative group. Our goal is to take solutions from wherever they are when they apply to a program to a place that they are more market ready, at getting multiple water companies involved in the process, so they split costs, share learnings, and the project in question happens fewer times across the sector. I spoke to the process in a little bit more detail this morning, so I won't bore you all again, but everything kicks off with our Ambition Surgery, our event today. We invite a great cross-section of the industry together, which is obviously you all, to help us articulate our problem space and begin to define the specific challenge the accelerator will focus on. Here, we're bringing relevant experts together to share insight, go through learnings, and define what a successful resolution of something in this space looks like. So what are we going to be learning about? What is our challenge area? As a reminder, we asked for different proposals from water companies. So with the help of Jeremy from SES, we went out to leakage managers and asked them to create proposals for what this accelerator challenge should look at, and then ask the water companies to vote on these proposals. So instead of starting with a kind of slightly blanker page like we have done in previous accelerators and previous ambition surgeries, we're going to be spending a lot of the time in this afternoon session understanding lessons from the past, yes, but also comparing and contrasting the 3 sub-areas on the screen here. They are cost-effective methods to find and fix trunk main leaks, low dig methods, and methods to identify and implement cheaper, quicker repairs. So the presentations and conversations that we're having today will, as I said, help us kind of compare, contrast these potential challenge areas and help us choose, refine, develop into something specific, actionable, which will ultimately lead into the writing of our call for innovation, which is the challenge that we put out into the world. This ultimately is our starting point. So with this starting point, this morning we had some great speakers giving us the context behind leakage and bursts from a technical perspective, a business one and a regulatory one. This afternoon, we're going to start by learning from things we've already tried in the space. So the first section is for us to share some lessons learned, outline some guardrails, maybe signal what the challenge shouldn't focus on, because we don't want to do things that we've already been done, that projects have already been run on in the space, right? Then we have a panel session to begin to outline the playing field, asking the types of things we need to do to understand, to measure, to take meaningful action. Basically, where should we focus our efforts to create genuine value for the sector? Then after today, we will take all the data, consolidate it into our call for innovation. And as I said, it's this call for innovation that we publish as our official challenge. What this means is at the end of the session today, we aren't necessarily expecting a perfect challenge statement. The purpose of today is to have interesting, productive conversations about our challenge area, getting insight from expert speakers, creating space for everyone to participate and share their knowledge, and for us, to get a little bit excited about the potential for innovation in the space and where there is value to be created. So we're going to kick off with 3 lightning talks, giving us some perspective on, ongoing and historical work at Welsh, Anglian, and Northumbrian Water. And then, as I say, we'll close with our great panel that will help us define these sort of boundaries and goals for our challenge. So yeah, we're in the afternoon session. If you missed this morning session and would like that more foundational context, that understanding of the area itself, we will be sharing the slides and the recordings actually after these sessions, so you haven't missed out. So yeah, I am really excited about the great speakers and panelists that we have for you this afternoon, but it's not all about them. Similar to this morning, we want to hear from you guys. We want to hear from the audience as well. And there are 2 ways that we're going to do this. First of all, we're going to have some Q&A moments. So as I think Kira's already posted in the chat, please feel free to pop the questions in there as they come up. Myself and the Spring team will feed them to the speakers, so don't feel you need to wait until the perfect moment to ask your question. We'll make sure we get to as many of them as we possibly can. And secondly, we also really deeply recognize that the expertise in the room extends beyond the speakers, right? So if and when you want to contribute to the conversation and offer your opinion on a topic that we're discussing, you can use this little dashboard, which I'll display in a minute. And then after the session, as I say, we'll feed all of your comments and suggestions into the creation of our call for innovation. So once you click on the link that we will post in the chat in just a moment, you'll be taken to a screen that looks like this. We have a handful of questions there already, similar to those that we're going to be asking throughout the day. So click on one, you'll be taken to the Slido board relating to that specific question, type in your answer and hit send. So really, please add your thoughts, ideas here. We really do value your input. And as I said, it's going to help us a lot in helping craft a call for innovation that is both relevant and valuable to the sector and to us as individual practitioners within it. So with that, I'm going to stop talking for a little bit. I will pop back up once or twice more today, but hand back over to Natalie to introduce the first of our speakers. Thanks, guys. See you soon.
Thanks so much, Thomas. And again, thanks everyone for joining today's session. Super exciting one. I'm going to kick off today's session with James Hargrave, Head of Leakage Operations at Anglian Water and Hartlepool Water. So with more than 30 years of experience in the water industry, James specialises in operational performance delivery and improvement, programme delivery and technology development and adoption for business as usual integration. Hopefully, I will get more of an understanding of what all of those words mean during the course of James's talk. Over to James.
Brilliant, Natalie, thank you. So yeah, good afternoon, everyone. I'm James. As Natalie said, I'm Head of Leakage Operations at Anglian Water. And for fear of sounding topically political, I choose to be in leakage, not because it is easy, but because it is hard. And I don't have any slides today. I'm just going to talk about a subject that I am passionate about. So leakage is hard. It's inevitable, it's relentless, but it underpins so many aspects of effective water network management. And as this is a forum to define problems and set challenges, I'm going to start by saying that nothing fixes everything. There is no golden bullet. There is, however, a Swiss Army knife of stuff that, when used in symbiosis with each other, can start to form effective leakage management and control solutions. So let's take smart metering as an example. Smart metering in isolation doesn't reduce customer side leakage. It is, however, an enabler for it. Simply installing a smart meter isn't enough. The success rate for customer side leakage reduction is reliant upon a water company's policies around repair and enforcement and their ability to engage with their customers, whether it be through new innovative virtual and digital channels or through traditional doorstop services. In our case at Anglian Water, smart metering is not just restricted to customer side leakage. Because our preferred install location is at the boundary of the property, our smart meters are also able to find leaks on outlets of external stop taps. Now, we wouldn't know that in pure data from the smart meters alone, and maybe there's a call to innovation there. But at present, the only way we can determine whether a leak is on our asset or on the customer's is through field investigation. However, it is still a solution that, under the right circumstances, can be used for network side leakage management as well. Another example, acoustic logging, is a subject that I'm extremely vested in. Whether it's through tactical lift and shift or strategic fixed network monitoring, no amount of AI-enabled software will actually reduce leakage. It can, however, increase the efficacy of find rate and enable effective leak detection pinpointing. But to reduce leakage and lessen the impact of CMEX, you need an integrated maintenance and repair program that looks to innovate repair methodologies that are less intrusive, more efficient, and quick to mobilize. So how do you build your end-to-end solutions and meld innovation, technology, and best practice together? What I'd like to do is just share an example of where the key to our success was in collaboration between us, the water company, and one of our suppliers. So back in 2018, we approached one of our suppliers with a proposition. They had two different products, and we wanted them to develop a new single product solution that was a combination of both. We started with our problem statement. We wanted a fixed in-position hydrophone network with remote data acquisition that could be scaled to either DMA or full system level monitoring. And we wanted an analysis software solution that would enable us to be able to overlay our network and repair information and be able to send summarized analysis data to our technicians in the field to support on-site investigation. Now, this product at that point didn't exist, and our supplier had to decide as to whether they were prepared to invest the time, effort, and money into developing a new product, where at the time no established market existed, or not. Thankfully, owing to an existing respected, credible, and trusting relationship, that company agreed to move forward with the development. Rather than step back at this point, we created a cross-company collaboration team with members from both our company and theirs to work on both the hardware designs and the software solutions. And this introduced real-time practical application aspects that ultimately led to a turnkey product that delivered on all of the original requirements. We began field installation trials back in 2019, and with further enhancements and development, we started to scale that program from 2 or 3 DMAs to what is now over 300 DMAs, monitoring more than 25% of our network. And rather than stop there, we kept the collaboration team running. And as we learned together, we further developed the hardware and software solutions. And through collaboration, delivery team engagement, and continuous review, we ended up delivering more than £4 million worth of efficiency that could be reinvested into scaling up the program. Fast forward to where we are today, and more than 40,000 leaks have been detected and repaired using this solution. All of this was possible due to one thing: a willingness by both the water company and the supplier to step into the unknown and work together as a team. If we were to do this today, it would likely be through the Ofwat innovation funding routes. So I suppose it posits a question, really: what are you waiting for? Is there more to do here, though? So, in the interest of sharing, with a smattering of showing off, I've stood on stage at many a conference and talked about this solution. It may not be the best solution for everyone. One of the drivers behind the decision to use hydrophones rather than traditional acoustics, for example, is because more than 50% of Anglian's rapidly growing network is plastic. And we know that hydrophones are more effective on plastic than traditional acoustics. However, they are equally as effective on metallic and AC pipes, which makes up the other 50% of our network. Having talked about this, over time, I've been approached by several leakage managers to find out how we use the solution to such success. And they've recently trialled the product and couldn't seem to get it to work well enough to justify further investment. My question back to them is always the same: how are you using it? Now, that may seem like an unhelpful question, given it's a hydrophone, it's installed on the network, and it's pretty turnkey. However, we didn't just co-develop the product solution. Internally, we further optimized our solution through our own standard of installation method and through the development of field investigation processes and performance management KPIs that maximize the return we get. Now, there's a fine line between collaboration, knowledge sharing, and competitive advantage. However, I'm always prepared to give the following simple advice: Don't install them on your fire hydrants or washouts. Find the ideal location to monitor your network, and make sure you engage with the field investigations teams through effective change management process. More than once, I've had leakage managers come back to me and say they still can't get it to work. And when I ask them where they're installing them, they usually answer on hydrants. And when I ask who is carrying out the field investigations, they usually say they're tier one outsourced leakage contractors. Now, I'm not saying that tier one contractors aren't skilled. However, there is a cultural alignment that's needed to fully integrate an end-to-end solution like this. I suppose the learning here is trust. I think as an industry, we still need to trust each other more, both water company to water company, supplier to supplier, and supplier to water company. Why do we still continue to trial the same products and the same type of networks and get different results? And why do we think of each product as an isolated solution and then compare the performance of different solutions using the same metrics, rather than using them in symbiosis with each other, the Swiss Army knife model, and then measure the output of them as a combined entity? For example, when looking for historic leakage in a large rural DMA, we use a mixture of satellite detection, virtual step testing, and the fixed network hydrophones. No single solution delivers the leakage benefit, rather it's the combination and application of the full tools at our disposal that delivers the end results. Each have their drawbacks and each have their strengths, but together they complement a thorough approach. That's all I have today, so I'll look forward to any questions that you might have. Thank you.
Thank you very much there, James, and also a great presentation. It really shows you know your stuff because it was just so off the cuff. I think for me personally as well, that question of ownership is of particular interest. I used to do some research in the lead space, and yeah, it's a little bit of a tricky one to solve. But thank you very much for your presentation today and for being here and joining us as part of this discussion of forming the call for innovation. It's much appreciated. Our next speaker today is Andrew, who's the Technical Policy Manager in the Leakage Strategy team at Northumbrian Water. He's got 15 years experience working on a range of roles within leakage, and is an active member of the leakage community who regularly attends industry events and participates in steering groups for UCWA leakage projects. Welcome, Andrew, and over to you.
Thank you very much. I will share my screen. Hopefully everyone can see that. I'll go to presenter mode. So yeah, I've got some slides to go through today. This was a presentation I went through last year at the Global Leakage Conference. I've just updated it with some new numbers, so apologies to those that have seen a lot of it before, but hopefully still some interesting stuff on here. So yeah, a few similarities with kind of what James was talking about, working with a supplier. This is the experience we've had with a company called Origin, who've developed a product called No-Dig. So the idea behind this was to try and repair leaks without having to kind of dig up and put a collar around and things like that. So it's repair from within the pipe. So first of all, what's in it? So it's quite a simple mix of water, a food grade gelin, and then some engineered calcium carbonate particles. Now these come in different sizes, and you know the different mix of these particles can be used for different situations, you know, depending on the type of leak and the material and things. So how this works, a slug of the No-Dig gets pushed into the pipe. We use the pressure then to move it along to the leak. The original thinking was that it would kind of escape out of the gap and then it would seal the ground around the pipe, stopping any water from being able to escape. But actually we found on some of the small leaks, kind of the pinhole leaks, it is actually kind of making a seal within the leak itself. And then once the repair's been carried out, any excess product is kind of flushed back out the pipe and taken away. So then this is all done, you know, very, very quickly and with minimal impact to the customers. So just a bit more detail about the journey we've been on with Origin. I think it very first started off in around the lockdown, kind of in 2020, when kind of initial tests were happening by Origin, kind of at home. And then in 2021 we started to work with them, and we did some tests on an abandoned main. So at that point we didn't have DWI approval, so we were using like an abandoned part of the network that was no longer connected. We managed to get it recharged and kind of test the repair method. We were pretty happy with that, and when DWI approval was granted in summer 22, we started to use it on the live network. So This table was from around 2023, so I think it has progressed since then. I couldn't get an updated version, but it was just to show that it kind of does work on a variety of materials and kind of failure types. You can see there in particular it doesn't work on kind of splits on alkathene and PVC. I think that's because of the method of pressurizing the pipe is would cause the splits to extend and kind of make them worse, so it doesn't actually seal them up. But overall, the majority of other things have kind of been repaired. So after those initial tests and kind of getting confidence that it did what we hoped it could do, we then set ourselves a challenge of kind of moving it more into kind of business as usual. So in April 2023, we wanted to apply the no dig repairs for all communication pipes where suitable. So part of our job raising process, we would get the technicians to kind of fill in the forms that would say whether they thought it was suitable. Did we have the assets available? Yeah, can we use no dig in this situation? And since that point, we've done over 1,000 repairs now in the Northumbrian region. So quite a significant amount of repairs have been carried out. From the latest data checked last week, our initial success rate, so that's around kind of the repair on the day that it stops the leak, is still kind of around 88%. So really high success rate on that initial repair. We have been doing some checks on kind of going back and reviewing them and making sure they're still holding. So we've got about a 6.5% failure on those on repeat visits. I'm not sure how proactive we're doing this, or whether we're just kind of picking a sample. But obviously those success rates are looking really good, over 80% overall at the moment from what we've been doing over quite a large range of jobs. Just some of the highlights. So even though we're focusing on compipes, we have done some tests on kind of larger mains. So they have repaired up to a 10-inch pipe, some long distances as well. So actually sending the product kind of over 1 kilometre down the pipe to then repair the leak, and obviously various different leak rates. The maximum so far about 2.5 litres a second, which is quite a significant flow to be able to repair with the no dig product. So like I say, we have done some stuff on trunk mains, distribution mains and customer supply pipes, but predominantly our focus has been on the comp pipes. That's where it seems to work best for us in terms of like the efficiency and the success rate. So that's really where we're using it for the majority of the time. Like I say, original test started in around 2021 on the abandoned main. So some of those have lasted from the very start. So we're getting up to a couple of years now that some of these repairs are lasting. But it is still a new product, and we're still learning as we go along how well this lasts. I just got a summary of some of the benefits. So kind of the leakage technicians don't need to pinpoint the leak, because the way that the product goes in, it'll get pushed along the pipe until it gets to the point of the leak, and then once the pressure increases and that you've reduced that escape, you can then bring it back out again. So you don't need to know exactly where it is on that pipe, as long as you know the section that you're working on. It's quicker, so less interruptions. We can get in and out, I think about 15 minutes, kind of get the product in and back out again. So quite a quick process, which then allows the resources to be used kind of smarter elsewhere. If we're not spending as much time on each job, that means we can use them on other work and higher priority things. It definitely reduces street work costs. It's quite a small footprint in terms of being able to get into kind of the boundary box. We're not having to kind of shut down roads and things like that, and again, traffic management significantly reduced as well. So I think we're working on kind of approximately 25% of like a traditional dig repair. It's reducing the carbon footprint as well, so zero waste to landfill, zero reinstatement, and that kind of thing. So lots of benefits along with this. We're kind of putting there some of the considerations, like I mentioned before. We are picking up some failures. We're still trying to collect that data and understand what is the long-term life of these repairs. Is it just a temporary fix? Is it to kind of stop the flow and keep it for a few years until we get down round, or enough failures that we would replace the pipe, or can it last for a significant amount of time? I think it's early days at the moment, and we probably need to do some more data collection. I think other companies as well have obviously been starting to use this product as well, and they'll be collecting data as well. So it'd be really useful to kind of get that together and understand what other people are finding. I think there's different methods where you can get this as a service where Origin will do the repairs for you, or you can train up your technicians to kind of get a delivery of the product and then kind of go and do the repairs themselves. So there's probably different methods of applying it, and understanding the pros and cons of each of those and the success rates will be really useful to kind of collect together as an industry. So I think that'd be a really worthwhile exercise to do. And just a final piece, kind of, I say it's very much been a relationship with Origin from the very start. Like James talked about, having that trust and working together to get something that works for you. That was very much the way we've worked with Origin. We have done a few customer supply pipe repairs. There's a potential whether we'd look at that in the future, whether we would look at it as a more proactive kind of system where you might not have a kind of a burst, a significant leak, but you might want to be able to use the product to kind of go through and seal up any small weeps and seeps as a bit more of like asset life extension. We'd love to be able to get it kind of working consistently on larger mains and being in trunk mains over long distances. And we've been looking at kind of combining this with satellite technology as well. So it's almost like doing the find and the repair. So if the technicians could have a backpack of the no dig, use the satellites, get a point of interest, and then find the leak, they could then repair it on site. So you're not having kind of the delay of kind of going into the repair system and waiting for a crew to be able to come out. So it's trying to speed up all that time from the find to the fix. Also looking at alternative options on kind of where we could use it in the raw water network and on kind of the sewer network in rising mains and things like that. So yeah, very much still we're using on the comp pipes as business as usual now, and looking at working at, like, you know, is there other areas where we could apply this technology as well. So that's everything I had to say on that. Yeah, fairly quick run through there. The contact details there for John at Origin Tech if anyone would like to get in touch. And yeah, if there's any questions, I'll pick them up from the chat in the Q&A. Thank you.
Perfect. Thanks so much for that, Andrew. That was a super interesting case study from you there. I think as well, I was like zooming in with my face into your last picture on the bunting. I was like, is that the Northumbrian Innovation Festival that I spot there? Is that the race course in the background?
It was, yeah, it was at the Innovation Festival. We got them to come down and do a demo. I think they've done it for the last couple of years actually. Yeah, so people can see how it works in the flesh kind of thing.
Interesting. I love like a hands-on demonstration. They're the best. Thank you very much for your presentation. We're now going to move on to our last presenter in this slot in the lessons learned section, which is Anna from Welsh Water. Congratulations on the new job role, by the way. So Anna is now project manager with Water Quality First. Anna is a curious innovator delivering change with over 16 years of experience in the water industry. She focuses on bringing ideas to life and embedding successful solutions. She does a lot of collaborative work, a lot of work with different partners, with UK universities, European water companies, SMEs, global businesses, and she builds on these experiences by leading and participating in Off-Water Innovation Fund projects and acting as a reviewer for the Discovery Challenge. So be nice to Anna, because if you're applying for that, you might have her to deal with. So welcome, Anna, and over to you for your presentation.
Great, thanks, Natalie. I'm just going to share my screen as well. Well, that's loading. Hopefully everyone can see that now. Is that in presenter mode? Brilliant. Thank you very much. So thank you for your time today. And I'm going to present to you about the Off-Water Innovation Fund project that was funded in WBC2 about managing background leakage. And to begin with, I just wanted to give an outline of who's who on our project. And as I've only got 10 minutes, I'm only going to touch on the surface of this particular project. But if you want to know more, please feel free to contact me and we can go into more detail of the project. So who's who of our project? We've got 5 water companies altogether, so alongside Welsh Water. We've also got Anglian Affinity, Portsmouth Water and Severn Trent. And we've also got University of Sheffield as our research partner. They carry out the research and analytics into our network leakage. And then we've also got Invenio and HWM, who are our fieldwork deployment partners, and they carry out the analytics into detecting customer side leakage. have we done so far? So to date, we finished phases A and B. A was looking into a report on the report of background leakage across the 5 water companies. So carrying out sort of a baseline of where we're at with background leakage. And then phase B is the start of our field work. In phase B, we deployed to 10 DMAs altogether that had a property count between 700 and 900 properties. And within that, we deployed as many stopwatch loggers as we could, acoustic loggers, standard pressure loggers, but also we installed 100 hertz pressure loggers as well to get that high resolution data on pressure loggers. All of this data was then used by the University of Sheffield and HWM to identify customer side leakage and network leakage. Also, we have currently started the phase C deployment. I'll go on to about phase C in a moment. So phase B is about flooding those DMAs, is getting as much information as we can to bring into our models to help us detect background leakage. To date, some of the techniques that we have developed during phase B is actually one of the biggest stumbling blocks that we came across was when we're actually reporting this information. Was if we're putting out images of the network, we needed to make sure that we were compliant with GDPR, but also to maintain the anonymity of that network. So the University of Sheffield came up with methods to I'd never be able to say this word. Basically, change the network so it keeps all of its hydraulic properties, but you wouldn't be able to identify that particular network just by looking at it. One of the other techniques that they have developed is looking at semi-automated routes for comparison of the measured DMA inflows, but also looking at the bottom-up demand that has been at the aggregation for the hydraulic models. And they've also been looking into methodologies for infilling missing customer data. Because one of the problems that we came across in phase B is that we weren't able to put loggers everywhere we wanted to for many different reasons. Either that cars were parked over chambers or they were in busy roads. They were our biggest problems that we had to overcome. So the University of Sheffield and HWM came up with methodologies of how to infill customer data without in fact affecting the uncertainty of the models we were producing. So from everything that we've been doing in phase A and phase B, we've been keeping a record of all of our lessons learnt so far and then taking what we've learnt to incorporate it within the work that we've been doing in phase C. So the main lessons that we've learnt so far is we needed to do more detailed review up front of any deployment or any selection of the particular DMA that we were looking at. And also in phase B, we encountered a lot of unexpected issues, raising, like I was mentioning before, access to stop taps, where there's no signal, so less signal, we can't receive the data. So what we decided to do is employ a soft survey prior to the full deployment. This was to iron out any niggles of access to stop taps, was there poor signal coverage, so that when we were actually going to the deployment phase, we were getting high amounts of data, high quality data that would ensure that the models that we were producing to detect customer side and network leakage to make sure that it was high certainty levels that we were having in our models. So everything that we've learnt in phase B, we're now putting into phase C. And that's where we're currently at the moment. So the next steps is that we are continuing the deployment into phase C. The difference between phase C and phase B is that in phase C we're actually deploying to 5 extra DMAs, so there's 15 altogether. We are going to have the same levels of pressure and acoustic logging, but we're actually going to pull back on the amount of stopwatch logging. And we're going to phase that across the DMAs. So as more DMAs, as we go through phase C, we're actually going to do less stopwatch logging and look at what is the impact on our ability to detect background leakage. And what we're also going to be deploying is we're going to be using the stopwatch light methodology, which will be using electronic listening sticks to detect noise. And where we are detecting noise, we're going to deploy a stopwatch logger. What we will also be doing, once we've finished all of our work in Phase D and Phase C, is holding dissemination events for early 2025 and also at the end of the project in November 2027, so that we can share all of our learning and all of our results to the people within the industry. So that is a very, very high level overview of where we've at, what we've done so far to fit into our lightning talk. But as I said before, if anybody would like to know more information about our results, what Phase B has shown us, please feel free to get in touch and we can arrange a Teams call.
Thank you very, very much for your presentation there, Anna. I think it's really important to be talking about some of the research that's ongoing at the moment. I think a lot of the time we can sometimes speak about research that we're hoping to do or research that's been done. So it's really exciting to listen about basically a work in progress, I think, between phases. So that was really good to hear.
Thank you very much.
And another great case study. Thank you. So I'm going to introduce Thomas to come back again and welcome all of our speakers from this session to turn their videos on. We've had some really exciting messages come through in the chat, plenty of questions. Feel free to drop more in and we will add you to that list of questions. Over to Thomas to lead our next session.
Yeah, thank you to the three of you for some great presentations there. I just want to start off with one for actually both James and Andrew. Someone called Tim in the chat is asking, what kind of contractual relationships did you have with the suppliers you worked with on innovating their technologies? And how much of the technology development and trialing was paid for by the water company as opposed to suppliers finding funding from other sources?
Do you want me to go first, Thomas?
Yeah, please do. Thank you.
So in the case study that I described, actually the supplier was the one that footed the bill for all of the development costs. It's worth making a point that the outcome product from that actually was their best-selling product, I think 2 years in a row following the final development. So it was a gamble that paid off for them, but they bore all those costs. I suppose the costs that we had from a collaboration perspective was time, effort, and the cross-team element, but there was no contractual requirement or obligation. It was an innovation-led, discovery-led development program that thankfully paid off for both us and the supplier.
Thank you, James. Andrew, what's the story with you guys and Origin?
Yeah, no, I think we had an exclusivity contract with them for, it was about 2 years, I think. So it was, I think we were probably paying like a monthly rate for them to cover the time, I suppose, the resources, and we obviously providing the network as well. But I think kind of in terms of the initial development of the product was probably already done when they came to us, and then it was more about kind of applying it. Where does it work? Where doesn't it work? Some of the, like I say, some of the kind of tweaking the formula of the size of the granules and things like that. So I think that there has been like a monthly contract, I think, and then there's like a call off against that in terms of what work they've actually done and the number of repairs and things. Now that I think the Compipe solution is available to market, that exclusivity came to an end. I think we might still have a contract for some of those other developments I was talking about, but yeah, the other stuff's now available to market.
Thank you. And Andrew, I'm going to stick with you for a second because there are one or two slightly more technical questions about Origin and Nodeg that I might kind of try and push together and see if we can rattle a couple of them off at the same time. So someone called Jamie from Severn Trent is saying that they also use the Nodeg now and have lots of success with compipes, but are interested in finding what issues you had found with mains, and just a little bit of detail on that. And maybe kind of tangentially related, what's the kind of maximum pressure the Origin can work under, and how does the point of injection work? Is it usually a boundary box or something similar?
Yeah, I've been trying to jot down the questions as well to answer as much as I can before we get to it. So with the mains, I think obviously bigger pipes, longer lengths. So again, I think it's a combination of kind of needing more product to be able to fill the pipe and get at that point. You need to put more in, so it's obviously kind of less cost effective. And I think you've then got less control over that pipe as well. Different connections coming in. If you might have different feeds along a main, so you might not be able to kind of keep the product where you need it, kind of thing. So there's probably some development how you get it to the point you need it to, or you would have to shut off any off takes and things like that. So it's just a bit more complicated. The compipe's quite nice. Obviously, it's smaller pipe. You know where you're working from. Yes, we do go in at the boundary box, kind of work. You push the product in back towards the main. So once the kind of pipe pressurizes and you've got that repair, you know when the leak's been fixed, and you kind of then draw the product back out and flush the pipe before putting it back into supply. It was an interesting one on the pressure. I'm not aware of any specific details on pressures. I think we're just kind of operating in the usual network conditions, so kind of between 20 to 150 meters, something like that in some cases. I'm not aware of any locations where we're not using it because of pressure, but again, probably a bit better data collection, looking into that a bit more, understanding where failures are happening and things like that could potentially be some of the cause of it. Probably don't know understand the impact of transients, and I think one of the other questions was around kind of the impact of some of the cleaning methods as well.
Right.
The majority of our work has been on compipes, so probably isn't getting affected by mains cleaning and things like that at the moment. But I would imagine, if you're putting something through scouring the pipe, potentially you could pull that seal back out. Again, a pressure transient, if you have a negative pressure wave, is that going to kind of pull it out? I suppose it depends on the size of that pressure transient and kind of how well it's sealed within the pipe itself. So I haven't got any specific details on that. I can imagine it would have an impact, but it's not really affecting us much at the moment.
Thanks, Andrew. Anna, we have one here from Courtney for you, which is, for any of the DMAs surveyed, have you managed to reduce leakage down to a level that might be considered background leakage?
What we've found so far is that every DMA is different. We've got some DMAs that we've seen has that all the leakage that we've detected is all customer side. Some we've detected that there's no customer side leakage, and all the leakage we've detected is in the network. So we are still going through all of that data at the moment. So it's kind of a yes and a no question, but one thing that I can say is that just the characteristics of every DMA we've looked at is different, and the results that we're getting is different. So it's a bit across the board at the moment.
Okay, thank you so much. I know we have so many amazing questions going on in the chat, and I'm sure our speakers can kind of come in and answer them as we keep going through. But just in the interest of time, today, I'm just going to thank our three speakers in this section, and we'll have to move on to the next one, into our panel. But please, guys, do stick around, answer some of the questions in the chat, and please contribute with your own questions, your own thoughts in the Slido surveys as well. I really appreciate your input so far today, guys. Thank you so much.
Thank you.
So, Natalie, it is now time for the panel. Could we please invite our panel speakers to do cameras on, mics on, all that good stuff, so that we can get kicked off with what I think is one of my favorite parts of these sessions, is the kind of deep dive explorations, conversations about what we should actually do with this accelerator challenge. We've got Joe, Jez, Olu, and Ian. Are you here? We'll just start doing a little bit of a preamble, as Natalie, maybe you have a wee look in the background just to see if we can make sure that everyone is here and ready to go. So yes, for anyone who has joined late, either this session or didn't manage to make it this morning, my name is Thomas. I look after the sort of innovation side of Spring's business, which includes our accelerator, which is why we're here. I have the pleasure this afternoon of, as I say, hosting this panel discussion, which is one of my favorite parts of an ambition surgery, to begin to narrow down the focus of Spring Accelerator 5's specific challenge. Because so far today, we spent a lot of time looking at leakage and bursts, talking about leakage and bursts by looking backwards. This morning, we aligned around this foundational understanding of what it means and why it's important to water companies, regulators, society writ large. And so far this afternoon, we looked at some examples of projects, initiatives, extracting some lessons and some watch outs for us. Now, I'm joined by a great group of experts who will introduce themselves in just a moment to flip our perspective a little and look to the future. So helping us to dig deeper into, the three potential challenge areas that we've worked to define and uncover the types of things we need to do to measure, to understand, to take action in the space. Ultimately asking the question, where should we focus our challenge, right? Where can we create the most value for water companies, customers, and the environment? As a brief reminder, we have about 40 minutes of discussion between us on the panel before opening up to questions for about half an hour for the audience. So folk in the audience, please remember to type your questions that you have in the panel in the chat. And we'll work like we did before to get through as many as we can. And finally, we will post the link in the Slido board one more time again now. And as I mentioned earlier, please do contribute, answer the questions, the same questions that we're going to be asking to the panel here, because we really do value your expertise, and we will use all of the information in our call for innovation. So maybe we can kick off with a round of introductions. Joe, you want to say hello first?
Hi, I'm Jo Parker. I feel like Methuselah compared with some people. Next year, I will have been in the water industry 50 years. I spent 30 of those with different water companies, Thames, Wessex, Affinity, so big, small, water only. And since I left Affinity, I've been working as an independent consultant, working on all aspects of the water network. And I manage a number of research projects for UCWIR. I've carried out research projects for UCWIR and other organisations. And I also act as technical advisor for about a dozen utility contractors who do self-lay. So that keeps me in touch with the front end, which I love. And I would say, like James, like Jez, I love leakage. I think it's a really interesting subject. Loads of high-tech stuff, but still the front end digging holes. So that's me.
Thanks, Joe. Afternoon, Ian. You want to say hello next?
Yeah, can do. Hi, I'm Ian Pemberton. For those who weren't on this morning's session, I've been in the water sector for about 35 years now, so I'm a relatively newcomer compared to Joe. 27 years of that was in consulting engineering, and been involved with leakage probably since Managing Leakage was published in '94. Joined off 8 years ago. Absolutely fascinating, because to me the appeal was to go further up the value chain and to be able to help form some of the policies and some of the to understand some of the stuff from a complete outcomes perspective. Joe mentions being there at the the front end of leakage and the innovations. I think one of the things I would say about Ofwat is that we tend to be at the back end of that, albeit that we are setting the outcomes. We see the amalgamation of all of the work and everything else sort of funneled together into one number, the annual leakage for the year, and the assurance that goes into that. So I think, from my background on the front end, to be able to see it from sort of end to end, it is very, very interesting. I kind of just would reiterate that Ofwat sets the outcomes that we expect to see for customer, society, and environment. Leakage being there, but we don't tell the companies what to do. We set the market conditions for it to be attractive for them to go and do the things that society thinks is right for them, and we certainly don't influence any kind of any use of technology or any endorse any one particular approach or one particular contractor or consultant. But what we do is very, very much promote innovation. So the Innovation Fund does I should think probably everyone on the call understands the Innovation Fund. That's at the sort of the front end early starter. And again, for those who are on the calls this morning listening to Jez, I think it's a really, really clear picture as to where Spring sits in that space. There's a definite difference in position from the Innovation Fund, from Spring, and from the company's own innovation projects. So yeah, more than happy to take any questions. I'm delighted to be part of the panel. Thank you.
Great to have you here, Ian. Thank you. Olu, how are you?
I'm good, thank you. And you?
Yeah, well.
Super. I'm Olu. Oluseyi Onifade, but you can just refer to me as Olu for short. I work with OCWE. So for those that are not familiar with OCWE, so it's an acronym for the UK Water Industry Research. So we carry out collaborative research for all the water companies in UK and Ireland. So no one left out, basically, on this side of the sea. So like I said, I look after some of our big questions, which are the challenges that the industry created about 10, 13 years ago now, looking at a lot of the things that the industry felt could be done collaboratively. So things like carbon abstraction, leakage, interruption, asset management, customers, carbon, sewage, wastewater, or that type of fun things. So we carry out research. So we do work together with Spring. We do sort of like the beginning of the TRL. So if you look at TRL1, TRL2, which is sort of the beginning of that scientific part of the research, and then sort of, as you know, Spring oversees when it comes to the innovation side. So Leakage is one of my babies, where I work closely with Jeremy and Joe quite a bit because of some of the leakage projects that we do together. So I'm quite interested in these discussions, and I'm looking forward to see how the day goes.
Amazing. Thanks, Olu. And last but not least, Jez.
So good afternoon. So I've been, you see, I feel like a relative newcomer now as well.
I'm a baby. That's why I didn't mention my term.
Yeah, I'm like a mere 32 years in the industry, I think it is now. So my background is that I've worked in operations departments of water companies, mainly at SES, but others as well, for many years. And in those roles, I've done kind of leakage, metering, GIS, all those kind of normal roles that you manage. 10 years ago, SES decided that innovation was going to become an increasing priority and asked me to step sidewards and work in that area. And about 6 or 7 years ago, I was invited to speak at the Leakage conference. Spoke at that, and I was invited along, I think, because I was an innovation manager who'd actually done leakage. And very much the idea is to say, don't worry, innovation's gonna help us reach the 15% reductions that we've got. And since then, I'm not going to say dragged reluctantly. I've embraced coming back into this area in terms of the leakage side, but bringing that innovation and research slant that I've been working on as well into this. And the last 5 years have been, I have to say, some of the most interesting in my career. As I said this morning, we are facing a really difficult challenge in halving leakage. I've travelled, I've been to other countries where they are reducing leakage to really low levels. What we're trying to do in the UK is do that without using massive mains replacement, and that is going to be so challenging. And if you'd asked me 5 years ago, was I confident we could do it, I'd have probably glibly said, yeah, I'm certain we'll step up to the challenge. I'm now appreciating more and more how difficult this is going to be. So Yeah, really pleased to be here, really excited to be here, because I think we are really embracing the challenge, and it is really going to be innovation that has to ride to the rescue to help us get down into those levels.
Great, thank you. So nice to have the four of you here. And obviously it's very, very clear your levels of technical expertise. But I am not a technical expert, just to put my hands up right now. So please forgive me if I ask for additional clarification, if I prod a little bit for my own understanding, and maybe for the understanding of some of the people in the audience who are perhaps newer to this topic. Additionally, please don't take offense if I start to raise my hand or something and maybe cut you off. We're a little bit tight for time here, so we will try and keep our answers as succinct but as detailed as possible. Just a quick plug again, please do. We'll post the Slido in the chat just now. Please do participate. Please do give us your thoughts, and also post any questions that you have to the panel in the chat as we go. Okay, to kick us off and to basically remind everyone of where we stand, we have 3 potential challenge areas that we will be discussing this afternoon. These have been created and prioritized by water company, leakage, and innovation managers. So for those of you who have been to Ambition Surgeries before, we're going to start in a slightly more focused place than we have done previously. And our role today as the panel, as the 5 of us, is to help us understand these challenge areas a little further and then see if we can keep prioritizing them. And if in fact we can begin to select and refine a challenge for the 5th Spring Accelerator program. So I'm going to start off just by giving a little introduction to these 3 challenges, and then open up to the panel to see how if I've got my definitions right, and what else we can do to kind of learn and think about these. So the 3 are cost-effective methods to find and fix trunk main leaks. So the way I understand that is affordable technologies or strategies to help detect and repair leaks in these larger diameter pipes that transport water over longer distances. Often water companies actually kind of estimate or know how much leakage occurs in these trunk mains using these estimation models, but are today managed quite reactively. So this challenge is really looking at means to identify and prioritize bursts in these trunk mains and implement methods to repair them, understanding the complexities of excavating large pipes. The second challenge area is low dig methods. So these are techniques that minimize excavation for repairing leaks and thereby reduce surface disruption associated costs. So water companies here are interested in solutions that would allow them to carry out selected water leak repairs at depths of about a meter or up to a meter without carrying out those excavations. So ideally about an A4 size piece of paper that we would sort of dig up, if you will. So this requires centimeter accurate location, wet environment excavations, and repairs happening in pretty low visibility environments. And the third, methods to identify and implement cheaper, quicker repairs. So this is basically innovation to make the repair process quicker, less disruptive to customers, and cheaper, right? This, I feel, and again, open up to the panel in just a moment, is a little bit more of a general one, and is looking for efficiencies in that entire PALM cycle of prevention, awareness, location, and mending. Jez, I see you nodding there a little bit. So maybe just on those 3 definitions, does that accurately characterize the issues? Would you suggest any modifications, different definitions to help us understand them a little bit better?
Thomas, no, that was really spot on. Actually, you nailed completely what we're looking for. I think let me just clarify a bit on the trunk main side. So currently, water companies have a methodology called BABE, where effectively we estimate the leakage on our trunk mains. We are moving over to flow monitoring zones where effectively we do a mass balance on that trunk main. Fine. That will give us an understanding of, is there leakage occurring on that trunk main? But your trunk main can be 10, 20 kilometers long. You haven't got many fittings on it to go and listen on it. So we've got to firstly, now that we're aware there's leakage on that trunk main, we've got to try and find it. And then even worse is when we come to repair it, we know that it's actually inside a farmer's field in the middle of nowhere. And actually, because you try and lay a trunk main to line and level, it's actually going to be 20 foot down. So it's some of the most difficult to find leaks, and it's some of the most expensive to repair leaks. Okay. And, as I say, my job is to kind of look over the horizon as an innovation manager. I know that as we start to introduce these flow monitoring zones across the UK, that's going to be an increasing problem that we're going to come across. So I want to start lining up solutions and already getting the word out there and going, look, this is going to be an issue for us.
Thanks, Jez. Joe, do you have anything to add that we can maybe help better define any of these challenge areas?
Well, Ian's got his hand up.
Oh, Ian, sorry, apologies.
I'm quite
Ian,
happy
please.
for him to come in.
Okay, I know my place. Just a point of clarification, Mr. Chairman, as they say. We were very careful in the new methodology to say to move away from the BABE methodology that Jez has just outlined there. I'm very careful to say more proactive methods, which I think is realistically probably is flow balances, but we're kind of not ruling out the art of the possible. So it's absolutely, if there's something more whizmo gizmo that's around this table or around the world that's better than flow balances, we're definitely not closing that one off. So it's a definite, as with the ambition that's being set out here to move away from the allowances method. But just a point of clarification that it is, if there's a whizmo gizmo that isn't flow balances that's going to get trunk main leakage fixed, bring it on.
Thank you.
So do you want me to come in now?
Please, Joe. Thank you.
I mean, as far as trunk main goes, they may not contribute the most amount of leakage, but they can totally scupper a water company achieving their outputs with just one failure. So knowing what's going to fail where is really important. Having said that, we're already seeing some new developments. That's not to say there isn't more that's needed. And I go back to James's Swiss Army knife. You need lots of different approaches for trunk mains as well as distribution mains. I will give but there are already internal inspection methods that maybe we should be thinking about using more. Maybe we need to think about how to access the main. And I'll give a shout out for Jez and his universal access point, because maybe that's the issue of actually getting into the trunk main. So that's there. As far as the other two projects, I sort of see one project as a subset of the other, but they're both incredibly important. But I think looking at the end-to-end process has never really been done from an innovation point of view. It's always just been maybe business improvement. And I'm not saying that's not an aspect of innovation, but not necessarily developing new tools and totally new methods. So I think that's an area that hasn't been looked at. I think all three descriptions are good, and I would heartily support all three.
Thanks, Joe. Ola, do you have anything to add here? Is Joe just said kind of maybe one nests inside the other. Is there a way that we can differentiate those in our minds, the kind of low dig methods and the kind of more general efficiencies in across PAM?
Yeah, I think a lot of the things works with how the water companies work with the supply chain. So if you look at the way it works, the low dig method, a lot of the excavation predominantly as at now are still outsourced to supply chain. So the water companies might be interested in looking and campaigning for no dig, minimum digs, zero digs, whatever we want to call it in that space of thing. But how much of that campaigning or working relationship have been developed with the supply chain? And I think this is where that collaboration element works. Supply chains, most of their money comes from digging. That is where their profit comes in. They love digging. So in order for us to move into the space of the low dig minimum, they need to be incentivized in other ways. Otherwise, the gangs out there will still always be looking at digging. I remember when I was in Southeast Water, and I'm thinking, why are you digging so many holes just to find the same leak And it's all because the people out there in the field, I'm not talking about the manager, I'm actually talking about the guys that dig themselves. The more they're out there digging, the more money that goes into their bank account. So that education needs to come from that space. And innovation is a part of it, but it's an element that needs to be worked together rather than instructed. And until we get to that space where we're working together and we're developing together, there is going to be an element of that supply chain where they're looking into doing the maximum excavation in which they can get to get the maximum profits in that way. And I think environment is a part of it. Some of our big questions look into carbon footprint. So that element from regulatory perspective, there needs to be more emphasis on supply chains that are doing the excavations to actually incentivize them and motivate them to actually do a lot more innovation and encourage the gangs as well to be doing in that space.
It's really interesting, Olu. Thank you. So obviously we have a sort of baseline definition, a baseline understanding of what these three areas are. I guess my next question to the panel is: do we agree with the leakage managers? Do we agree with this prioritization that has happened sort of before this event today, that these three challenges should in fact be our top priorities for intervention in leakage and bursts? And if so, if not, what challenges do you think are equally or more critical? Joe, I'll start with you here.
Well, I do think they're really good, three really good challenges. Jez has already talked about the fact that, this is 52% of the total leakage cost. And actually, for every leak, it's rather more than that if you take a single leak as opposed to the end-to-end process. And as I've been banging on about this internationally for quite a long time. 10 years ago, I presented to an international conference on leakage, and the presentation was called "The Fat Lady Sings," because, that quote, "It ain't over till the fat lady sings." Well, you haven't got rid of the leak until you've repaired it. And actually, until you've repaired it properly, because you do get, sadly, repeat leaks because the repair wasn't done properly the first time. So maybe that's just one aspect that could be looked at, not necessarily innovation, but just making sure how can we get repairs done right first time, every time. That would eliminate cost, but and I'm sure that Ofwat would be very happy to see that happening. But I think the only other thing is that about 20 years ago, I was involved in a project called The Real Cost of Street Works, where we looked at external costs. And I think this is the thing that people forget. It's not just about the water companies. Every time we do a repair, we damage at best the pavement, and a lot of the time it's the road surface. We shorten the life of the road. We interrupt business activities. We prolong journeys. We have cars sitting maybe at temporary traffic lights, spewing out contaminants, and it adds to the, as Ollie said, adds to the carbon footprint. So these are really important projects, not just for the water industry, but for UK PLC. And maybe one thing that would be good would be to update those costs and say, what are these repairs costing in total, not just the water industry.
Yeah. Ollie, do you have anything to add there?
Yeah, sorry, I'm nodding along because I do agree with it, because it seems interesting that it kind of feels like he's working in isolation in a way. And I think even from water companies that do have direct labors, how much are we doing internally with regards to innovation space and with regards to minimum technology, with regards to trunk main monitoring, with regards to flow monitoring and all those things. And I think sometimes that we need to do a lot in-house to show that leadership by example, and then it's then easier to actually impose it on our supply chain. And I think one of the things we also need to look at is, I always say water is a commodity. It should be on the stock market. If it's on the stock market, everybody will focus on it. There will be more funding, not just from the regulators, not just from customers, but from people with deep pockets, really, in essence. And I think that is one of the issues that we also do have, that not seeing that element of water as a commodity is not allowing that expensive innovation to actually come in for us to be able to do a lot of the things we want to do, and also to actually get the future ready people, which is kind of linked into this, because we are talking about things that can't be solved now but will be solved in future. So how much are we actually bringing the young people that are in the university these days that are actually looking into? I went to asset management conference a couple of months ago, and they were talking about people just doing gamification, but what they know and what they do can be applied. And those are the type of people we need for the modeling, for the trunk monitoring in that way. So it's adopting that knowledge and actually transferring that skills into us. And I think that's where it kind of comes in, that we need to campaign more about what we do and with regards to water as a commodity to actually help us solve some of these challenges.
Yeah, okay, thank you. It's really interesting. Ian, I think it's quite clear that leakage and bursts, or innovation inside leakage and bursts, is a relatively mature space, right? But despite this, these three challenges that we have articulated, they persist, right? They haven't been solved yet.
Mhm.
I guess the question is, why do you think this is? Is it a problem hierarchy thing? Are there technological, economic, regulatory barriers? Is it an adoption problem, not an innovation problem? Or is it solved elsewhere and we just need to go and pick up technology from another country, for example? Why are these three issues not resolved?
That's a really good question, and it answers all of the above, I would say. That's the simple answer. Once we were pushing towards economic levels, early post privatization, there was a drive down. Then, as we looked at leakage economics, it stabilized and plateaued, and then the customer and societal and environmental relationship with water has very much changed. In the last, I guess, 10-15 years. The little bits I've learned about economics, that they would call it an elastic market, when you basically add one more unit to the market because you can add it and you can sell it. Well, it don't work like that with water resources. It is a finite resource. So those the leakage economics kind of go out the window, as we heard from Bob Taylor this morning. That's a different thing. So we have reacted to the changing, trying to use the wrong word, environment, climate, as in social environment, rather than exterior weather and environment. And then, as Jez has said, that mains renewal and mains replacement potentially has a place. I have to say that I've not seen a convincing argument that mains replacement actually is the solution. I'm not saying it isn't out there, but I'm just saying I haven't seen it, and we looked at it a little while ago. So there's definitely some stuff to do with that. And then in terms of innovation space, I think it's again what we've discussed this morning, and I can see it in the comments there about Reg 31 and and things, materials in contact with water and the like. The setting very high standards, and the companies achieving very high standards of water quality compliance and lack of interruption to supply. Has kind of driven that sort of space as well. And I guess the risk to reward thing, that's only really just been brought in PR 14 and PR 19, and so to turn around and say actually there is a financial and a reputational benefit to the companies in outperforming. Previously, it has always been, thou shalt achieve this standard, and if you don't achieve it, if you fall below it, you'll face the wrath of the regulators and the wrath of prosecutions and the like. But actually, to turn around and say, if your customers want a higher level of performance, and if we're willing to pay for it, then you should be incentivized to deliver it.
Yeah, absolutely. Jez, do you have any opinions on this? Obviously, with the sort of roadshow you did, you've had exposure to a lot of different leakage innovations. So why haven't the ones that are undoubtedly in this space already, or these spaces already, why haven't they stuck?
So I think the bit that we've seen is this hierarchy that I was talking about, this kind of Maslow's hierarchy of needs, is that everybody starts with awareness. Okay, so regardless of where you go in the world, everybody starts with going, okay, are we aware where leakage is actually occurring? Yeah, where do I deploy people to go and look for it? Is it on my trunk mains? So it's either geographic areas or in your structure, in terms of if it is on trunk mains, distribution mains, or whatever. So you start off with an awareness side of trying to go, where is the leakage? Once you go, okay, we're now aware that we do have leakage. Where do I actually go and carry out repairs? That's your location piece, and therefore companies tend to go into the location. And then beyond that, they then go, okay, actually, we're getting a handle now on trying to do this. Okay, how do we stop leaks happening in the first place? And therefore, people then start to move into prevent. And then that tends to do your kind of pressure management and things like that. And depending on how much money you've got, they'll just go, actually, do you know what? Let's just replace our entire network. And that's the prevention bit done. Okay, and therefore that will stop everything. And that tends to be where things stop. That's why we see so little stuff going into the MEM bit, because you go awareness, location, and then you go into your prevent, and then you're kind of right, okay. The other bit behind that is very often when you talk with a company, with a water company, it's a completely separate department that deals with the repair side. Yeah, it's nothing to do with your leakage budget whatsoever. It's another department. The only time leakage talk with the repair side is when the work in progress gets too much and they give them a bit of a kicking and say, can you drive it down? We've got leaks that are long outstanding. So it tends to be managed in a completely separate way. And that's one of the reasons why we use this PALM methodology, is to get it into people's heads. Actually, that's got to be managed as much as your awareness and location piece and your prevention. You've got to be looking at how do we speed up these repairs? How do we deal with these repairs as well? So I think that's one of the main reasons why it hasn't been done. It's not been traditionally associated with leakage. It's seen as being somebody else's area, somebody else's problem to deal with. Yes, it impacts upon leakage, but they don't control it directly.
And can I come in here?
Please do, Joe.
Yeah, overseas was mentioned. Actually, no one internationally is doing anything to improve how they do repairs. It's amazing. I have stood up at so many international conferences in all over the world, and they're just not looking at it. And I've been doing this for 10 years, and finally people are starting to think, oh yeah, now I've been able to publish the really interesting information. I would be saying, well, about 60 to 70% of the cost of a leak is the repair. But now we can actually say, well, in the UK, we have this regulatory information that shows that 52% of leakage management, not just one leak, is 52%. And people internationally are starting to look at this information. So it is an area where potentially we could lead the world, because no one else is looking at this.
I completely agree with Joe, and I think that's the bit for all the supply chain that are on this call today. If we can get a good solution in the UK, the rest of the world will be absolutely all over this. They're looking at us anyway, because we are driving down leakage without, as I said, massive mains replacement. The eyes of the rest of the world are on the UK, because they want to know how we're going to do that. Yeah, we've got 15 plus water companies all trying slightly different permutations. I always say it's a bit like Formula One. Yeah, we're all trying slightly different permutations in order to achieve the same goal. Yeah, but the really interesting bit is, unlike Formula One, we're actually sharing, I did this and this is how it worked and this is what it did to my speed and things like that. Yeah, so everybody around the world, there's a massive focus on the UK at the moment and understanding the methodologies that we're using. So yeah, solve this one. I can tell you now, this will go worldwide.
Yeah, definitely.
Absolutely.
Amazing. So I guess speaking about the UK, or I guess specifically speaking about England and Wales, there is a large regulatory focus over the next AMP on leakage, right? I think there's a 13% reduction in leakage down to the lowest level since privatisation as one of the Ofwat targets. Olu, which of these areas, if we take maybe just the two, because I feel like we were singing the chorus of the mend space here. So the no dig methods or the trunk mains leakage. If we take those two areas, which do you believe offers the most opportunity to achieve that goal of 13% reduction in leakage?
I think it's a bit of both, because as Joe said earlier on, trunk main burst leakage, you don't find them often. They're not common. But you only takes one to actually blow you completely out. So there is element of that. And then you've got the element of the low dig, minimum dig part of it. I think that is looking at cost, but not necessarily the reduction in the leakage part of it, because the more we're focusing on that technology to actually get the minimum or the low dig, it means you're leaving that at the moment where we stand currently, the leak is being left to run a lot longer. So you've got the more continuous leak you have, you've got that problem of you eating a target. But I think we've got those two. But I think one third thing, which is not on the list we've got to bring in, is with regards to smart metering. The level of smart metering that would be installed over the next 5 years would contribute, because you're going to find a lot more leakage. And that would contribute to achieving that target of the 13% as well. So it's not a single component that would contribute to achieving it, but it's a mixture of all of them. So I can't really give a specific answer to choose one. I think we just got to work on all of them together.
Right, absolutely. I think James said it really well earlier today when he talked about the Swiss Army knife of approaches. I guess from a Spring point of view, a selfish Spring point of view, we're looking to set a challenge, and we're looking to choose one if we can. Ian, where do you think we could have the most impact?
Go on. So is that Joe? Trying to speak. Sorry. Okay. I was just going to add a little bit to that. Is the definition? Like I said in my bio, the definition and the reporting of leakage. At the moment, it's unaccounted for water in the UK, and there's a whole bunch of assumptions made in that water balance, and a whole bunch of calculations and estimations. So there's definitely a lot of work to do in terms of improving the understanding of water balance. And that's kind of why I was giving the sort of the note of caution around trunk main balances for trunk main leakage. Because if you then have take into account the metering accuracy and the number of components in those balances, it's not just a straight, it's not a no-brainer to go from BADE to balances. There's a whole bunch of challenges to overcome in doing that. I think I guess I've always said to my colleagues when they ask about leakage, you could halve your current reported levels of leakage if you could repair the exact same number twice as quickly. Because so you actually, if you could do it for the same price twice as quickly, you'd halve your leakage for no budget. So so I think there's definitely some stuff to do there on the speed. I completely take the point that that speed and low dig are probably two sides of the same coin. They probably are. And then if you can get to low dig, then the highways authorities and the other utilities will facilitate that happening. So there's definitely a whole bunch of stuff to do around that as well.
Interesting. Thank you.
Yeah, I do think that if you put the wording carefully for the second and third options, you could actually cover them both. I'd like to see wider than just low dig, because there are all sorts of other ways, as Ian quite rightly says. If you can speed up the process, you reduce leakage for no cost. But outside of that technological answer of low dig, it becomes very complicated. We're talking about collaboration, and it may well be you have to collaborate, for instance, with local authorities, highways authorities, which are not always the easiest people to collaborate with. And you may get them accepting, one might accept an approach. You've then got, well, I'm not actually sure how many highways authorities there are in England and Wales, but it's a lot of negotiation required just to get it across the whole of England. But the benefits could be immense if you manage to do it. So I think it is worth the effort. And I'd love to see things streamlined, working efficiently. And, for instance, one thing I'd love to see is more robotics in repairs. I've always said, youngsters don't want to work in repairs. They think it's hard work. But you give a control console managing a remote control digger, they'll be queuing up for the job. It's, every kid, perfect job. So I do think we've got to work on this, because something people haven't mentioned is the shortage of people to do these repairs. Mm-hmm. And we've got to get people into the industry.
Yeah, thank you, Joe. Okay, Jez, last comment, and then I'll ask my final question.
I was just looking at the chat as we're going through as well, and I just wanted to pick up on Matthew's comment, if that's okay.
Please.
So looking at the kind of unaccounted for water side as well, and you're spot on in that we are still discovering, whether it's leakage or unaccounted for water. Now, what's happening there is when you look at the breadth of the water companies, there are some that are kind of leaders and some that are followers in terms of where they are with leakage. And certainly the leader ones are now getting into situations where they're really struggling with DMAs. Is it actually leakage in that day? DMA, isn't it? And so there's a number of projects that are going on to really get a better understanding. So part of that is your analysis algorithms. So at my company, we've moved to 1 minute data, and that's really helped tidy up our understanding of whether it's leakage or whether it's actually usage and things like that. So that helps a lot. Some of the other work that's going on, you've already heard about the work that's been going on looking at background leakage, and that's been a really useful project because that's effectively so far kind of as you heard, said, look, we're not exactly sure. We're trying to get that characteristics of a DMA that helps us to understand, is it actually leakage or isn't it? So there's an Ofwat funded project that's doing that. We've just completed a project looking at smart metering data and saying, can we use smart metering data to increase our understanding of that? And it's evident that you can use, even with a relatively small proportion of smart metering in a DMA, it really tidies up your understanding of whether it's leakage or whether it's just, actually in your allowances and things like that. So there's a lot of work going on in that area to try and understand that better. I'll pause there, Thomas. I just wanted to pick up on that.
So just before I ask the sort of final question around the horn to the panel here, I just want to remind everyone, please do fill out that the dashboard, the Slido dashboard survey. It is not just a survey, but it is your way of having your voice heard in crafting the call for innovation. So we really do appreciate it. Natalie's posted that again in the chat just a moment ago. Specifically, we're also interested in hearing your answers to this final question that we're gonna pose to the panel now. So, if Ian, you were in our position, how would you frame the call for innovation to attract specific implementable solutions in this space? What challenge should we focus on?
It would be delivery of outcomes. It would be how does your innovation actually help us deliver an outcome? What is the benefit of that? I think we were talking earlier on about that innovation potentially having a cost associated with it, and I think I spoke earlier on about the risk that goes, that companies are not funded to take risks, and nor should they with customer money. So hence us creating the innovation fund in the innovation space. But actually, hopefully we've created the environment where companies can invest towards spend to save. So if there's something which is actually going to get them a better outcome, so the challenge to me would be for the innovators on this call, be able to demonstrate or at least sort of showcase what the tangible benefits are that can be achieved by that innovation.
Thank you. So, Olu, I know we kind of touched on that Swiss Army knife comment a moment ago, but where would you focus if you had to choose one area for the challenge to be focusing on? What would you pick?
I think for me it would be the low dig, the minimum technology, and I think Joe clearly stated it very well. It's not something that is being done. or focused on globally. So it gives us an opportunity to actually champion this. And I know that with regards to the pipe bots project that was being done by Sheffield, Birmingham, and the likes, this is something that is still relatively new. So it's something that we could focus on, we could get our teeth into. And I think also it's something that is easier for us to actually get collaboration outside of the sector with regards to people that might be interested in this. So I think that would be my key thing for me.
Thank you. Joe, do you agree?
Yes, although maybe I'd word things so that if people had an idea of ways they could just reduce the cost, the end-to-end cost of repairs. So if people had good ideas of other aspects, as I said, robotics is one, and possible, even looking at the relative costs of repairs externally, so that might help local authorities to get on our side to work with us. So I think if we allowed facilitators as well as the actual technology and worded it in such a way, as Ian said quite rightly, it's about outcomes, and it's about reducing, I would say, the total cost of repairs. And if that is actually a benefit to local authorities and highways, then maybe that opens up funding from other areas. So I'd like to make it wider than just low dig, but I think gas are already doing it. So there's lots of potential out there.
And then just to be clear, we do encourage applications from out of sector for our accelerator as well. Yeah. So be great in that case to pull some lessons and some technologies from other places. Jez, before we open up to the audience questions, what's your opinion? What should our call for innovation be?
So I would actually go for the quicker, cheaper leak repairs one. I think, as Joe said previously, that kind of encompasses low dig could be a subset of that, because it would be quicker and cheaper doing it that way. So I think for that reason, I would probably go for that. And I think if we looked at quicker, cheaper, I'd probably slightly reword it. Rather than just talking about cheaper, I would talk about the value. Because these days we don't just talk about the value as being the cost of something. We also look at the environmental aspects. We look at the carbon and everything else like that. So I would go for that one, and that brings in for me a wealth of other areas. That's not just dig methodologies. In order to speed up that, in order to do it quicker, that's about your location technologies being as accurate as possible. Yeah, it's about your understanding of what's underneath the surface before you dig. There's a wealth of technologies that we could bring into that area that would help us do that quicker. And it's not even just technologies in there. Part of that, I'm convinced, will be reorganization. It's procedural work in terms of how we collect data and how we talk with other departments and how we talk with other companies in order to make that more effective, in order to speed up that repair process. So yeah, for me it would be that one, but with a slight wording change. Instead of cheaper, better value.
Thank you so much. Okay, so going to open up to audience questions now. We've been capturing a lot of them, so I'll do my best to make our way through as many as we can. I'm going to start with one from Sarah from Yorkshire Water. Jez, speaking to your comment, talking about the solutions developed to repair leaks in the UK would be applicable globally. Sarah's sort of, I guess, challenge to that is that solutions that we might need in the UK and Ireland might be overly expensive for other countries. If they have to meet Reg 31, have to be inside the 3-hour interruption to supply window. Is it too much for other places?
So it's interesting when you look at regulation. Regulation exists all the way across the world. Yes, we have tight regulation in the UK, and certainly I'd agree with you. Sarah, in that the solutions that we'll be producing will probably work better at the moment in the highly regulated areas. Okay, and that'll be Europe. That's your kind of Australians and people like that, who have very similar regulation to us, and a lot of those actually built their regulatory systems around what we did first. So I think it would start there. I think for me, the worldwide, and here I am thinking long term, climate change is coming. In fact, it's already here in terms of where we are. Okay, we're dealing with mass breakouts in the summer, and we're trying to repair those as quickly as possible. Yeah, when we get those. If we're struggling with that, and we are well up in the northern hemisphere, I can tell you every other place around the world is going to be dealing with that as well. Yeah, quicker, cheaper, faster repair systems when your reservoir is dropping like a stone will be wanted absolutely everywhere. Yeah, and that to me is that's where you'll start off from, and then eventually as you get those kind of solutions in place, you'll start to use them all the time because your crews will be far more trained in them and things like that. But part of this is not just the day-to-day running of our leakage networks, it's also how we respond to catastrophic events. Believe you me, the leakage managers, none of us want to go through 2022, 23 again, where we were absolutely struggling to stay on top of the bursts that were coming in. And if I could have half that burst runtime simply because I have better ways of doing it, I would have, I won't say what I would have done, but I would have paid a lot of money for it.
Thank you. Joe, there's another question here talking a little bit more about customer side leakage that's responsible for up to 40% of overall leakage, and the fact that water companies have varying strategies and policies here. So should there be a role of a universal policy to tackle leakage more effectively, like a sector-wide leakage strategy, if you will?
Well, Ian has talked about, water companies are not told what to do. It's up to them to decide how to do it. The good thing about having different strategies is that you can look at how they're working. Jez mentioned collaboration, and I think it would be worthwhile looking at options, and provided you weren't contravening any sort of market issues, it's worthwhile saying, well, what works best with customers? Plus, what do customers want? Well, they probably want us to do everything and take over the supply pipe. And maybe, that is maybe more of the consideration. And it has been discussed and it has been looked at. And it may be one way to get on top of that customer side leakage. But of course, it's not just the external leakage. You have then got to get on top of the internal plumbing losses. So that's a whole new area. I mean, maybe that'll be another call. And yes, it's important, but let's focus on the repairs, because that is a lot of money and we can get a lot of benefit from that.
Thank you. Jez.
Yeah, I was just going to jump in there, and hi, Michael. But talk about alignment in terms of policies, and you're absolutely right. Every water company has its own strategy and policy about what repairs we'll carry out on customer side and things like that. I think, it's interesting actually, when that policies came in, it was John Prescott who originally turned around and said, wouldn't it be great if your water company repaired your supply pipe? That's where it originally started from. Water companies then started to bring in policies to do that, but it is a hodgepodge of who does what. So my gut reaction and what we're seeing at the moment within the industry is that there is starting to become an alignment. And what's driving that is smart metering. Because as soon as you start to bring in smart metering, it forces you to change your policy. Because we're finding that typically when we bring in smart metering, we're finding 10 times the amount of leaks and things like that. So it's almost a forced policy change that's coming through within the companies in terms of, okay, how do I deal with 10 times the amount of customer side leakage that I previously thought I had and detected? Yeah. And that tends to drive a drawing together in terms of policies. So my gut reaction is I think you will find over the next 3 or 4 years a huge movement in terms of aligning our company policies together as we all move into this smart metering era.
Thanks, Jez. Ian, there's a question here. Be interested to get your take on, which is the Jez, a different Jez in the chat, is wondering how be interested to understand what measurable leakage benefit we could see through whole-scale DMA level mains replacement. It's obviously hugely expensive, so difficult for companies that dedicate the funds to deliver the benefit, given all the other challenges the industry is faced with. But do we need to take off our quote unquote leakage blinkers and look at our networks more holistically to fully understand the additional benefit achieved in terms of water quality, supply interruptions, resilience from an approach like this?
Oh gosh, again, a real belt of a question. Thank you. Like I said earlier on, there has definitely been a call to say we should do wholesale mains replacement. In my consultancy days, leakage wasn't the driver for mains replacement. It was pressure, water quality complaints, mean zonal compliance, and burst frequency. So there were other drivers towards the mains replacement program. And I think also where we've seen, where there's been mains replacement, and then if you're going to put the mains in, you end up with potentially significant numbers of bursts on the connections as well. So post installation. So yes, you then have to look at what do you mean by wholesale DMA replacement, and how you do that. I think. Again, I think when I first joined Ofwat, I met with one of the water companies who kind of made a really valid point, is that the customers want to see us as a sector managing our network right. And if we've got to get in, do what you got to do it right. If you've got to dig a big hole, if you've got to be there for three days instead of 1 day, come in, do it, and then go away and don't come back. So actually get in, do what you got to do. If I've got to take a bit more pain for you to do it right, and then that's an issue. So you could turn around when you talk about these low dig and no dig solutions. If we're then going to be going and diving in and doing absolutely spot repairs, and each of those has temporary traffic lights and a generator outside it for 3 days, it might be the right solution for leakage, but it might be the wrong societal holistic solution.
I think, can I just jump in as well, Thomas, is that we, in a sense, we're too late to do that. To do massive mains replacement programs where we are at the moment is we would really struggle in the UK. And one of the reasons for that is the complexity of our systems and what we've got out there. So I'll give you an example. Mile End Road in London. Thames Water have a scheme that they put in. This is available on the internet. You can look this one up, so I'm not giving away anything. They put in to do 1 mile of mains replacement in Mile End Road, and the budget for doing that was £20 million. Now, it doesn't cost that much to put pipe in the ground, I can tell you. So therefore, it's all the additional costs that get put on top of that. It's route, it's traffic disruption, it's the councils, it's lost business, and all of those other things that now get put in terms of that we have to think about. And when I joined this industry 30 years ago, that wasn't the case. Okay, it's now enormously more complex and disruptive to dig up every single one of our roads, and do a massive mains replacement program. And certainly we've got to think about how we do that. And it's interesting, you're seeing in the UK a lot of focus on whether we can do no dig repair renewals and things like that, or low dig renewals as well. So I think the days when we could have just gone and ripped everything out and started from scratch again, the cost for our customers will be absolutely astronomical, and the disruption as well.
Thanks Jez. Olu, there's a question here asking how much do we think of the leakage challenge is known leakage and how much is an unaccounted for water issue. Basically, the question is, are we missing a different improvement opportunity, a better understanding of UFW, unaccounted for water, not just at a DMA level, means that subsequent activities can be better targeted. Is there something that we're missing here with unaccounted for water versus leakage?
I think to some degree, if you can account for it, then it is missing. So therefore, automatically interpretation is that it's leaking somewhere within that whole structure. I mentioned that I have an analogy which I use quite a lot, which is about the sausage factory. If you've got a fork of meat or all the everything that they use in making sausages through a grinder, and you weigh it goes in, you weigh it out, it should be relatively similar to what you put in. If you're not getting that, then something is missing in that component of that machinery. So if you've got unaccounted water, and you've got, especially with the fact that we're all looking into the smart metering now, where you should know exactly what your customers are using. If it's not calculating and it's not equating to each other, then that means to some element of degree, there is leakage somewhere. It might not be through the customer pipe, it might not be through DMA level, it might not be through the trunk mains, it might not be, but there is leakage somewhere. So it could be in your production site, it could be in your reservoir. But that is not calculated as leakage. That would be calculated as not being used, or it's not leakage in that way. So to me, it is leakage in a way, just that whether it's a regulatory calculated leakage or not.
Yeah. Joe.
Yeah, I just thought I'd mention a while ago, someone who used to work for me in Affinity Water actually got a job at Buncefield Oil Depot. And I went to visit him and talk about, how he found it compared with the water industry. And it was really interesting because he said the big difference is in measurement, because their metering is so accurate and they're measuring temperature so that they can take into account the impact that has on the measurement of the product. Now, I think it was Jez who talked about, the value of the product earlier. I'm sorry if I've got the wrong person, but one of the issues we have is that it currently our product is considered, low value. I say considered, and as it gets less available, it will, become far more highly regarded. And so actually, I think there's mileage to be had to measure what's going through the process more accurately. But the first step of that is smart metering, because if you don't know what's coming out at one end, then you've got no idea about the inaccuracies further up. And so I think, that's part of the process. But I'd like to think that smart metering will drive these questions, which will then drive improvements in other metering and more accurate metering further upstream.
Understood. Ian, do you have something to add to that?
It was just really an anecdote. I remember going to a conference at the National Engineering Laboratory in Glasgow, probably late 90s, and there was a chap from the petrochemical industry, as Joe has mentioned there, saying about the level of accuracy, and it was phenomenally accurate. It was less than 0.1% accuracy. But to do so, because it's a non-conductive fluid, they were putting ultrasonic meters on and having pipes going the whole length of a supertanker to come on through. So the custody transfer meters were that accurate. And he was delighted because with the new technology, he'd got it down to less than £500,000 per meter. Delighted. That was noteworthy. Wow. They got it down to £500,000 per meter.
Incredible. Okay, with that inspiring anecdote, I think we'll bring this panel conversation to a close. Just want to say thank you again to the four panelists. It's been a really great and lively discussion. We really value that all of your input so far, and we look forward to keeping you abreast of all the stuff that's going on with the challenge as we keep moving. Thank you so much. Thank you so much, guys.
Thank you for having us.
I'm just gonna briefly wrap up the call just as we end here today. As I say, I think that was a really interesting and insightful discussion. And I would love basically to just start the conclusion by saying thank you. This one, as I've mentioned a couple of times, has been a slightly different ambition surgery. It's part of a continued iterative process to make sure that we are, delivering as much value as we can to the sector. We really appreciate you all coming on the journey with us. Big thank you to all the speakers for giving such an amazing overview and deep dive into everything leakage, for Natalie for doing such a great job of keeping us on track behind the scenes, to Jez for all the work in defining the areas that we discussed today, and to Kira and Ellis, the Spring team, and Jamie for working away in the background to making sure all the technology is happening and there isn't any kind of major hiccups, and obviously to everybody that's joined us today for contributing to the next Spring Accelerator Challenge. As I'm sure you can tell, we've got quite a bit of work to do after this amazing discussion today. We've got a couple of weeks to draft and work with the water companies to help define what the call for innovation would look like. But specifically, we need to digest all the information from both from the speakers and from everything that you've all provided in the background on the surveys and the like, and then iterate, build something for launching again in the next few weeks. Really, that's it from me and from us today. The Slido will remain open for a little bit of time, so you can contribute as much as you want. We'll send the slides over as soon as we can, slides and recordings of the session, so you have access to all of that stuff if you want to go in deeper. And yes, as Natalie is currently saying in the chat, we also have a Spring Accelerator 4, challenging emerging contaminants in wastewater, open until the 25th of November. So please, if that's another topic here that's interesting for you, have a look at that challenge on our website. Thank you all so much. Hope you enjoy the rest of your day, and have a good one. Thank you.